Write the order of heat of combustions of the following compounds, and the compounds are given by two double bonds containing compound like this. This is a trans alkene system with two trans bonds. One is trans and one is cis double bond, and next one is cis followed by what? Cis double bonds. In this case, trans and trans system is present. In this case, one is trans followed by cis system is present. In this case, cis followed by cis system is present. All together, if they undergoes heat of combustion, those of all are converted to corresponding equal amount of carbon dioxide, equal amount of water, plus some amount of heat energy is getting liberated. Whereas here the product quantity of the in terms of carbon dioxide, in terms of water is remains same, and the reagent consumed, that is oxygen, is also same. Molecular formula of the starting material is also same. All of them are isomers, geometrical isomers to one another. As being all the starting materials are isomers, quantity of oxygen required is same, amount of the products formed are also same, but the heat energy depends on relative stabilities. Whereas this particular combustion process is an exothermic process. In every variety of combustion, maybe it is material 1, material 2, material 3, everywhere what happens, heat energy is getting liberated. The process becomes an exothermic process. Now, if I graphically depict the corresponding heat of hydrogenation related information, heat of combustion related information, then the starting materials with different energies makes a sense over the amount of energy liberated in the combustion reactions, which is of exothermic reaction. Let us go what happens in case of combustion reactions. Suppose let us go for a generalized reaction, Aron reaction with oxygen giving oxide related and the water related compounds as products followed by heat energy is liberated is general example of the combustion. Whereas heat energy liberated implies product is having lesser energy compared to the reactant. This is general mathematics that we can apply. The energy of the reactants plus, this is elemental form, energy of the reactant and energy of oxygen will becomes equal to energy of the product plus heat energy implies reactant and the product signs, suppose oxygen in the elemental form if you don't consider. So therefore here reactant energy will becomes equal to product energy plus some heat energy implies total heat content related information comparison. Content comparison of heat reveals the information that heat content of reactant is greater than that of the product, and the difference will appear as heat of reaction. So therefore, graphically, diagrammatically, if you look at, this is related to the energy, whereas here energy is present on the y-axis, whereas here reaction coordinates are present on the x-axis. Here our starting material is reactant, here our after some time it is converted as what? Product. Whereas here whatever the energy difference is there between the reactant and the product, this is known as delta H. This delta H is known as enthalpy of combustion. Whereas in our case we are having trans and trans compound, we are having trans and cis compound, we are having cis and cis compound, but the product formed is same. Whatever the product is there, that product formed is same. As being product formed is same implies what? This is the product, this is the product. Now the energy of the reactants makes a sense. So more energy of the reactant implies what? More energy of the reactant implies more enthalpy of combustion, more amount of energy is getting liberated. Now here, out of them, cis and cis is having more energy compared to trans and cis, compared to trans and trans. From here, whatever energy is liberated, trans and trans related energy is like this. Whereas here, trans and cis related energy is like this. From here, cis and cis energy liberated is like this. Suppose if I write, this will be the reaction. If I write, this will be the reaction. If I write, this will be the reaction. So therefore, energy liberated in the trans and trans will be minimum. So therefore, trans and trans is minimum. Cis and cis is maximum, and trans and cis is what? Medium. That is enthalpy of combustion. Enthalpy of combustion in terms of isomers is decided by the energy of the isomers, that is the stability or the energy of the reactant isomers, whereas that isomer whichever is having highest stability liberates least amount of enthalpy of combustion, whereas that isomer which is having highest energy, that is lowest stability, offers more amount of enthalpy of combustion. So therefore cis and cis case, cis and cis isomer, what is meant by cis and cis isomer? This is our cis and cis isomer, this is our trans and trans isomer, like this. So therefore trans and trans isomer offers less, cis and cis offers more, whereas cis and trans offers what? Very medium amount of energy is getting liberated.